Hydrocarbons. Objectives. After studying this unit, we will be able to name the hydrocarbons according to the IUPAC system of the nomenclature, recognize and write structures of the isomers of the alkanes, alkynes, and the aromatic hydrocarbon, learn about the various methods of the preparation of the hydrocarbon, distinguish between the alkenes, alkynes, and the aromatic hydrocarbons on the basis of the physical and the chemical properties, draw and differentiate between the various conformations of the ethane, appreciate the role of the hydrocarbons as a source of the energy and for the other industrial applications, predict the formation of the addition products of the unsymmetrical alkenes and the alkynes on the basis of the electronic mechanism, comprehend the structure of the benzene, explain aromaticity and understand the mechanism of the electrophilic substitution reaction of the benzene, predict the directive influence of the substituents in the monosubstituted benzene ring, and learn about the carcinogenicity and the toxicity. So, hydrocarbons are the important sources of the energy. The term hydrocarbon is self-explanatory, which means compounds of the carbon and hydrogen only. Hydrocarbons play a key role in our daily life. You must be familiar with the terms LPG and the CNG used as fuels. LPG is the abbreviated form of the liquefied petroleum gas, whereas CNG stands for the compressed natural gas. Another term, LNG, liquefied natural gas, is also in use these days. This is also a fuel and is obtained by the liquefaction of the natural gas. Petrol, diesel, and the kerosene oil are obtained by the fractional distillation of the petroleum found under the earth crust. Coal gas is obtained by the destructive distillation of the coal. Natural gas is found in the upper strata during the drilling of the oil wells. The gas after the compression is known as the compressed natural gas. LPG is used as the domestic fuel with the least pollution. Kerosene oil is also used as a domestic fuel, but it causes some pollution. Automobiles need fuels like the petrol, diesel, CNG. Petrol and the CNG operated automobiles cause less pollution. All these fuels contain mixture of the hydrocarbon, which are sources of the energy. Hydrocarbon are also used for the manufacture of the polymers like the polyethylene, polypropylene, polystyrene, etc. Higher hydrocarbons are used as solvents for the paints. They are also used as the starting material for the manufacture of the many dyes and the drugs. Thus, you can well understand the importance of the hydrocarbons in your daily life. In this unit, we will learn about the hydrocarbons. Now, the classification. Hydrocarbons are different types depending upon the types of the carbon bonds present. They can be classified into three main categories: saturated, unsaturated, and the aromatic hydrocarbons. Saturated hydrocarbons contain carbon-carbon and the carbon-hydrogen single bonds. If different carbon atoms are joined together to form open chain of the carbon atoms with the single bonds, they are termed as the alkanes, as you have already studied in the unit 12. On the other hand, if carbon atoms form a closed chain or a ring, they are termed as the cycloalkanes. Unsaturated hydrocarbons contain carbon-carbon multiple bonds, double bonds, triple bonds, or both. Aromatic hydrocarbons are a special type of the cyclic compounds. You can contrast a large number of the models of the such molecule of both types, open chain and the closed chain, keeping in mind that carbon is tetravalent and hydrogen is monovalent. For making models of the alkanes, you can use the toothpicks for the bonds and the plasticine balls for the atoms. For alkenes, alkynes, and the aromatic hydrocarbons, spring models can be constructed. Now the alkanes. As already mentioned, alkanes are the saturated open chain hydrocarbon containing carbon-carbon single bonds. Methane is the first member of this family. Methane is a gas found in the coal mines and marshy places. If you place one hydrogen atom of the methane by the carbon and join the required number of the hydrogen to satisfy the tetravalence of the other carbon atom, what do you get? You get C2H6. This hydrocarbon with the molecular formula C2H6 is known as the ethane. Thus, you can consider C2H6 as derived from the CH4 by the replacing one hydrogen atom by the CH3 group. Go on constructing the alkanes by doing this theoretical exercise. Replacing hydrogen atom by CH3 group, the next molecule will be C3H8, C4H10, etc. These hydrocarbons are inert under the normal condition and did not react with the acid base and the other reagents, since they were earlier known as the paraffins. पैरम का मतलब होता है लिटिल और एफिनिटीज का मतलब होता है एफिनिटी. कैन यू थिंक ऑफ द general formula of the alkane family or the homologous series. If we examine the formula of the different alkanes, we find that the general formula of the alkanes is the CnH2n plus 2. It represents any particular homolog when n is given appropriate value. Can you recall the structure of the methane? According to the VFEPR theory, methane has a tetrahedral structure in which carbon atom lies at the center and the four hydrogen atom lie at the four corner of the regular tetrahedron. All the HCH bond angles are of x0 degree point for x0 degree का. फिर structure of the methane in alkanes tetrahedra are joined together in which the C and the CH bond lengths are 151 picometer or 112 picometer respectively. We have already read that CC and the CH sigma bonds are formed by head-on overlapping of the sp3 hybrid orbitals of the carbon and 1s orbitals of the hydrogen atoms. Now the nomenclature of and the isomerism. We have already read about the nomenclature of the different classes of the organic compounds in Unit 12. Nomenclature and isomerism in alkanes can further be understood with the help of a few more examples. Common names are given in the parentheses. First three alkanes, methane, ethane and the propane have only one structure, but higher alkanes can have more than one structure. Let us write a structure of the for the C4H10. Four carbon atoms of the C4H10 can be joined either in a continuous chain or with a branched chain in the following two ways. तो ब्यूटेन एन ब्यूटेन इस तरह से जिसका बॉइलिंग पॉइंट 273 केल्विन है और 2 मिथाइल प्रोपेन आइसोब्यूटेन जिसका बॉइलिंग पॉइंट 261 केल्विन है. तो अगर ब्रांचिंग बढ़ेगा तो बॉइलिंग पॉइंट घट जाएगा. इन हाउ मेनी वेज यू कैन ज्वाइन 5 कार्बन एटम्स एंड 12 हाइड्रोजन एटम्स of the C5H12. They can be arranged in 3 ways as shown in the figure 3 to 5. पहला है कि पेंटेन जो कि एन पेंटेन है जिसका बॉइलिंग पॉइंट 309 केल्विन है. फिर 2 मिथाइल ब्यूटेन आइसोपेंटेन जिसका बॉइलिंग पॉइंट 301 केल्विन हो जाएगा. फिर 2 डाईमिथाइल प्रोपेन नियोपेंटेन जिसका बॉइलिंग पॉइंट 282.5 केल्विन. यानी कि जिस से ब्रांचिंग बढ़ रहा है वैसे वैसे बॉइलिंग पॉइंट घट रहा है. तो स्ट्रक्चर 1 and the 2 possess same molecular formula but differ in their boiling points and the other properties. Similarly, structure 3, 4 and the 5 possess the same molecular formula but have different properties. Structure 1 and 2 are isomers of butane, where structure 3, 4 and the 5 are the isomers of the pentane. Since difference in the property is due to difference in their uh, structure, they are known as the structural isomer. It is also clear that the structure 1 and the 3 have continuous chain of the carbon atoms, but structure 2, 4 and the 5 have a branched chain. Such structural isomers which differ in the chain of the carbon atoms are known as the chain isomers. Thus, we have seen that C4H10 and the C5H12 have the 2 and the 3 chain isomers respectively. Write the structures of the different chain isomers of the alkanes corresponding to the molecular formula of the C6H14. Also write the IUPAC names. तो पहला ये हो गया एन हेक्सेन, फिर 2 मिथाइल पेंटेन, 3 मिथाइल पेंटेन, 2 3 डाईमिथाइल ब्यूटेन और 2 2 डाईमिथाइल ब्यूटेन. Now based upon the number of the carbon atoms attached to a carbon atom, the carbon atom is termed as the primary, secondary, tertiary or the quaternary. Carbon atom attached to no other carbon atom as in the methane or to the only one carbon atom as in the ethane is called the primary carbon atom. Terminal carbon atoms are always primary. Carbon atom attached to the 2 carbon atom is known as the secondary. Tertiary carbon is attached to 3 carbon atoms and neo or the quaternary carbon is attached to 4 carbon atoms. Can you identify 1 degree, 2 degree, 3 degree and 4 degree carbon atoms in the structure 1 to 5? If you go on constructing a structure for the higher alkanes, you will be getting a still larger number of the isomers. C6H14 has got 5 isomers and C7H15 has 9. As many as 25 isomers are possible for the C10H22. In the structure 3, 4 and the 5, you observed the CH3 group be attached to the carbon atom, the number added 2. You will come across groups like the C3, C2H5, C3H5, etc. attached to the carbon atoms in the alkanes or the other classes of the compounds. These groups are substituents are known as the alkyl groups as they are derived from the alkanes by the removal of the one hydrogen atom. General formula of the alkyl group is CnH2n plus 1. Let us recall the general rules for the nomenclature already discussed in the Unit 12. Nomenclature of the substituted alkanes can further be understood by considering the following problems. Now the Write the structure of the different isomeric alkyl groups corresponding to the molecular formula C5H11. Write IUPAC names of the alcohol obtained by the attachment of the OH group at the different carbon of the chain. तो स्ट्रक्चर ऑफ द C5H11 कॉरस्पॉन्डिंग अल्कोहल और नेम ऑफ द अल्कोहल दिया हुआ है। तो पेंटेन 1 ऑयल है, यह पेंटेन 2 ऑयल, यह पेंटेन 3 ऑयल क्योंकि यहाँ पर है। फिर ये हो गया 3 मिथाइल ब्यूटेन 1 ऑयल, फिर ये हो गया 3 मिथाइल ब्यूटेन 1 ऑयल और 2 मिथाइल ब्यूटेन 2 ऑयल, फिर 2 डाई मिथाइल प्रोपेन 1 ऑयल और 2 मिथाइल ब्यूटेन 2 ऑयल हो गया। नाउ दी नोमेनक्लेचर ऑफ ए फ्यू ऑर्गेनिक कंपाउंड्स, जैसे 4 इथाइल 2 मिथाइल हेक्सेन इसका नाम है। तो इसका रिमार्क्स क्या है कि लोएस्ट फॉर्म एंड द अल्फ़ाबेटिकल रीअरेंजमेंट। फिर इसका नाम हो जाएगा 3 डाई मिथाइल 5 आइसोप्रोपाइल 4 मिथाइल ऑक्टेन और इसका रिमार्क्स है कि लोएस्ट फॉर्म एंड द अल्फ़ाबेटिकल रीअरेंजमेंट। फिर इसका हो जाएगा 5 सेक ब्यूटाइल 4 आइसोप्रोपाइल डेकेन और इसका सेक इज नॉट कंसिडर्ड वाइल अरेंजिंग द अल्फ़ाबेटिकली, आइसोप्रोपाइल इज टेकन इज एज वन वर्ड। फिर इसका हो जाएगा 5 डाई मिथाइल नॉनेन, फर्दर नंबरिंग टू द सब्सटेंट ऑफ द साइड चेन। फिर 3 इथाइल 5 मिथाइल पेंटेन हेप्टेन है, तो अल्फ़ाबेटिकल पायरेटिव ऑर्डर इसका हो जाएगा। फिर है राइट द IUPAC नेम्स ऑफ द फॉलोइंग कंपाउंड्स। तो पहला हो गया C3C2 C3 के 3, फिर C3 के 2 C2H53 टेट्रा टर्ट ब्यूटाइल मीथेन, तो 2244 टेट्रा मिथाइल पेंटेन, 33 डाई मिथाइल पेंटेन और 33 डाई टर्ट ब्यूटाइल 2244 टेट्रा मिथाइल पेंटेन। तो it is important if it is important to write the correct IUPAC name for a given structure, it is equally important to write the correct structure from the given IUPAC name. To do this, first of all, the longest chain of the carbon atoms corresponding to the parent alkane is written. Then after numbering it, the substituents are attached to the correct carbon atoms, and finally valence of each carbon atom is satisfied by putting the correct number of the hydrogen atoms. This can be clarified by writing the structure of the 3-ethyl 2,2-dimethyl pentane in the following steps. Draw the chain of the 5 carbon atoms, give number of the carbon atoms. उसके बाद attach ethyl group at the carbon 3 and the 2 methyl groups at the carbon 2. Satisfy the valence of each carbon atom by the putting required number of the hydrogen atom. Thus we arrived at the correct sequence if you have understood writing the structure from the given name. Attempt the following problems. तो पहला है कि write the structural formula for the following compounds. पहला कि 3,4,5 टेट्रामिथाइल हेप्टेन और 2,5 डाइमिथाइल हेक्सेन, तो इसका हो जाएगा ये और इसका हो जाएगा ये। क्वेश्चन नंबर 13.5 की राइट स्ट्रक्चर फॉर ईच ऑफ द फॉलोइंग कंपाउंड्स, वाई आर द गिवन नेम्स इनकरेक्ट, राइट IUPAC नेम्स। तो पहला है 2 इथाइल पेंटेन और 5 इथाइल 3 मिथाइल पेंटेन, तो इसका हो जाएगा longest chain is of 6 carbon atoms and not that of 5, hence the correct name is 3 methyl hexane. और दूसरे के लिए कि नंबरिंग इज टू बी स्टार्टेड फ्रॉम द एंड विच गिव्स द लोएस्ट नंबर टू द इथाइल ग्रुप, हेंस द करेक्ट नेम इज 3 इथाइल 5 मिथाइल हेप्टेन. नाउ द preparation. Petroleum and the natural gas are the main sources of the alkanes. However, alkanes can be prepared by the following method. From the unsaturated hydrocarbons, dihydrogen gas add to the alkenes and alkynes in the presence of the finely divided catalysts like the platinum, palladium or the nickel to form the alkanes. This process is called the hydrogenation. These metals absorb dihydrogen gas on their surface and activate the hydrogen-hydrogen bond. Platinum and the palladium catalyze the reaction at the room temperature, but relatively higher temperature and pressure are required with the nickel catalyst. तो इथीन हो गया और उस पर से इथीन बना दिए, फिर प्रोपेन से प्रोपेन बना दिए और प्रोपाइन से हम प्रोपेन बना दिए। उसके बाद फिर आता है अल्काइल हैलाइड्स एक्सेप्ट फ्लूइड्स ऑन द रिएक्शन विथ जिंक एंड डाइल्यूट हाइड्रोक्लोरिक एसिड गिव्स द अल्केन। जैसे क्लोरोमीथेन से हम मीथेन बना सकते हैं। फिर आता है क्लोरोइथेन से इथेन बना सकते हैं और 1 क्लोरोप्रोपेन से प्रोपेन बना सकते हैं। अल्काइल हैलाइड्स ऑन ट्रीटमेंट विद द सोडियम मेटल इन द ड्राई इथेरियल फ्री फ्रॉम मॉइस्चर सॉल्यूशन गिव द हायर अल्केन्स. दिस रिएक्शन इज नोन एज द बुर्जी रिएक्शन एंड इज यूज्ड फॉर द प्रिपरेशन ऑफ द हायर अल्केन्स कंटेनिंग द इवन नंबर ऑफ द कार्बन एटम्स. जैसे ब्रोमोमीथेन है, उसमें ड्राई ईथर से इथेन बन गया, फिर ब्रोमो इथेन से ड्राई ईथर मिलाएं तो एन बुटेन बन गया। Now what will happen if two different alkyl halides are taken? So from the carboxylic acid. Sodium salt of the carboxylic acid on heating with soda lime mixture of the sodium hydroxide and the calcium oxide give the alkanes containing one carbon atom less than the carboxylic acid. This process of the elimination of the carbon dioxide from a carboxylic acid is known as the decarboxylation. जैसे CH3COO माइनस Na प्लस NOH में CaO किए तो CH4 प्लस Na2CO3 बन गया. इसको कहते हैं सोडियम इथेनोएट कहते हैं इसको. A problem है कि sodium salt of which acid will be needed for the preparation of the propane. Write the chemical equation for the reaction. तो ब्यूटेनोइक एसिड है C3C2COO माइनस Na प्लस NOH CO मिलाएं तो C3C2C3 Na2CO3 बन गया. Now the Kolbe electrolytic method, an aqueous solution of the sodium or the potassium salt of a carboxylic acid on electrolysis gives alkane containing even number of the carbon atoms at the anode. जैसे C3COO minus Na plus H2O सोडियम एसिटेट इलेक्ट्रोलाइसिस किया तो C3CO2 plus H2 plus NOH बन गया. This reaction is supposed to follow the following path कि C3COO minus plus Na plus C3COO minus plus Na बन गया और एनोड पर क्या हुआ कि C3COO minus plus 2 इलेक्ट्रॉन C3COO और C3 plus CO2 बन गया. एसिटेट आयन एसिटेट फ्री रेडिकल और द मिथाइल फ्री रेडिकल. फिर एट कैथोड पर कि H2O प्लस इलेक्ट्रॉन OH माइनस प्लस ये और H2 प्लस ये मीथेन कैनॉट बी प्रिपेयर्ड बाय दिस मेथड. वाई. उसके बाद फिर आता है प्रॉपर्टीज. तो फिजिकल प्रॉपर्टीज अल्केन्स आर ऑलमोस्ट नॉन पोलर मॉलिक्यूल बिकॉज ऑफ द कोवेलेंट स्ट्रक्चर ऑफ नेचर ऑफ द C single bond C and C single bond H bonds are and due to very little difference of the electronegativity between the carbon and the hydrogen atoms. They possess big van der Waals forces. Due to the big forces, the first four members C1 to C4 are the gases, C5 to C17 are the liquids, and those containing 18 carbon atoms or more are the solid at रख दें. They are colorless and odorless. What do you think about the solubility of the alkanes in water based upon non-polar nature of the alkanes? Petrol is a mixture of the hydrocarbons and is used as a fuel for the automobiles. Petrol and the lower fraction of the petroleum are also used for the dry cleaning of the clothes to remove the grease stains. On the basis of this observation, what do you think about the nature of the greasy substance? You are correct if you say that grease mixture of the higher uh, alkanes is non-polar and hence hydrophobic in the nature. It is generally observed that in the relation to the solubility of the substances in the solvents, polar substances are soluble in the polar solvents, whereas the non-polar ones in the non-polar solvents like dissolves like. Boiling point of the different alkanes are given in table 13.2, from which it is clear that there is a steady increase in the boiling point with increase in the molecular mass. This is due to the fact that intermolecular van der Waals forces increase with the increase of the molecular size or the surface area of the molecule. You can make an interesting observation by having a look on the boiling points of the three isomeric pentanes, namely pentane, 2-methylbutane and the 2,2-dimethylpropane. It is observed that pentane, having a continuous chain of 5 carbon atoms, had the highest boiling point 309.1 Kelvin, whereas the 2,2-dimethylpropane boils at 282.5 Kelvin. With increase in the number of the branched chain, the molecule attains the shape of a sphere. This results in the smaller area of the contact and therefore the big intermolecular forces between the spherical molecule, which are overcome at relatively lower temperature. उसके बाद फिर आता है chemical properties. As already mentioned, alkanes are generally inert towards the acid bases and the oxidizing and reducing agents. However, they undergo the following reactions under the certain conditions. पहला है substitution reaction. One or more hydrogen atom or of the alkanes can be replaced by the halogens, nitro group and the sulfonic acid group. Halogenation takes place either at the higher temperature 573 से 773 Kelvin or in the presence of the diffused sunlight or the ultraviolet light. Lower alkanes do not undergo nitration and the sulfonation reaction. These reactions in which the hydrogen atoms for the alkanes are substituted are known as the substitution reaction. As an example, chlorination of the methane is given below. तो halogenation CH4 plus Cl2 H2 CH3Cl chloromethane plus HCl फिर CH3Cl plus Cl2 H2 डाइक्लोरोमीथेन और CH2Cl2 plus Cl2 H2 ट्राइक्लोरोमीथेन और CH3 plus Cl2 H2 टेट्राक्लोरोमीथेन बन गया. तो वेरिएशन इन द मेल्टिंग एंड द बॉइलिंग पॉइंट इन द अल्केन्स। तो जैसे CH4 है, मीथेन, इसका मॉलिक्यूलर मास 16 है, मॉलिक्यूलर मास इसका 16 है और बॉइलिंग पॉइंट है 111। इथेन हो गया C2H6, मॉलिक्यूलर मास 30 और बॉइलिंग पॉइंट 184। तो जैसे जैसे नीचे जा रहे हैं वैसे वैसे बॉइलिंग पॉइंट बढ़ते जा रहा है। और कुछ केस में जहाँ पर जैसे पेंटेन और 2-मिथाइल ब्यूटेन 2,2-डाइमिथाइल प्रोपेन, इसमें इसमें है कि ब्रांचिंग बढ़ने पर बॉइलिंग पॉइंट कम हो रहा है और मेल्टिंग पॉइंट का जो ऑर्डर है वो कुछ इस प्रकार का है। उसके बाद फिर हेक्सेन में, फिर हेप्टेन में, ऑक्टेन में, नॉनेन में, डेकेन में, और एक आता है ईओकेफेन में जिसको कहते हैं इकोफेन, जिसको 20 और 42 आ जाता है, उसको इकोफेन कहते हैं। उसके बाद फिर आता है CH3 Cl2 प्लस HNO CH3 Cl क्लोरोमीथेन प्लस HCl बनेगा। इट इज फाउंड that rate of the reaction of the alkanes with halogen is F2Cl2, फिर Br2 और फिर I2। rate of the replacement of the hydrogens of the alkanes is 3 degree, 2 degree, 1 degree। fluorination is too violent to be controlled, और iodination is very slow and a reversible reaction। it can be carried out in the presence of the oxidizing agent जैसे HiO3 और the HNO3। फिर CH4 प्लस I2 CH3I प्लस HI और HiO3 प्लस 5HI I2 प्लस H2 बन जाएगा। Halogenation is supposed to be pursued via free radical chain mechanism involving 3 steps, namely initiation, propagation and termination as given below। फिर mechanism इसका आता है कि initiation, the reaction is initiated by the homolysis of the chlorine molecule in the presence of the light or the heat। the CCl bond is bigger than the CC and the CH bond and hence the easiest to break। जैसे CCl HNO homolysis तो chlorine free radicals बन गया। अब propagation, chlorine free radicals attacks the methane molecule and take the reaction in the forward direction by breaking the CH bond to generate the methyl free radical with the formation of the HCl। तो CH4 प्लस Cl HNO CH3 और HCl बन गया। फिर आता है the methyl radical thus obtained attacks the second molecule of the chlorine to form the C3Cl with the liberation of another chlorine free radical by homolysis of the chlorine molecule। तो C3Cl HCl और chlorine free radicals बन गया। The choline and the methyl free radicals generated above repeat steps A and B respectively and thereby set up a chain of the reaction। The propagation step A and B are those which directly give principal products, but many other propagation steps are possible। May occur two such steps given below explain how more highly halogenated products are formed, जैसे कि C3Cl प्लस डॉट Cl C3Cl2 और HCl और CH2Cl Cl ब्रेकिंग तो C2Cl2 ये बन जाएगा। फिर आता है टर्मिनेशन, द रिएक्शन स्टॉप्स आफ्टर सम टाइम ड्यू टू कंजप्शन ऑफ द रिएक्टेंट एंड और ड्यू टू द फॉलोइंग साइड रिएक्शन। द पॉसिबल चेन टर्मिनेटिंग स्टेप्स आर Cl2 बन जाएगा, फिर C3 बन जाएगा, फिर C3Cl बन जाएगा। Though in the C3Cl the one of the products is formed but free radicals are consumed and the chain is terminated। The above mechanism helps us to understand the reason for the formation of the ethane as a byproduct during the coagulation of the methane। फिर आता है combustion। Alkanes on heating in the presence of the air or dioxygen are completely oxidized to the carbon dioxide and water with the evolution of a large amount of the heat। जैसे CH4 प्लस O2 CO2 प्लस H2O बन जाएगा जिसका डेल्टा H माइनस 890 किलोजूल पर मोल है। फिर C4H10 प्लस 13/2 O2 4 CO2 और 5 H2O देगा जिसका डेल्टा H कम्बसन हीट ऑफ कम्बसन माइनस 28,2875.84 किलोजूल पर मोल है। तो the general combustion equation for any alkane is कि CnH2n प्लस 2 में 3n प्लस 1/2 O2 मिलाएं तो n CO2 और n प्लस 1 H2O बन जाएगा। Due to the evolution of a large amount of the heat during the combustion, alkanes are used as the fuels। During the incomplete combustion of the alkanes with insufficient amount of the air or the dioxygen, carbon black is formed which is used in the manufacture of the ink, printer ink, black pigment and as the filter। तो CH4 प्लस O2 इनकम्प्लीट कम्बसन किए तो C प्लस H2O बन जाएगा। कंट्रोल्ड ऑक्सीडेशन, alkanes on heating Alkanes on heating with regulated supply of the dioxin or the air at a high pressure and in the presence of the suitable catalyst gives a variety of the oxidation product जैसे CH4 प्लस O2 Cu प्लस 523 केल्विन 4 atm पर CH3OH यानी कि मिथेनॉल बन जाएगा। फिर CH4 प्लस O2 MO2O3 कोई कैटलिस्ट है उसके प्रेजेंस में मिथेनल बन जाएगा, मिथेनल बन जाएगा। फिर आता है C3O2 C3COO2 Mn के प्रेजेंस में इथेनोइक एसिड बन जाएगा प्लस 2H2O। फिर आता है ordinary alkanes resist oxidation but alkanes having tertiary H atoms can be oxidized to corresponding alcohols by the potassium permanganate। जैसे C3CH के MnO4 ऑक्सीडेशन किए हैं तो C3COOH2 मिथाइल प्रोपेन बन जाएगा। फिर आता है आइसोमेराइजेशन। N-alkanes on heating in the presence of the anhydrous aluminum chloride and hydrogen chloride gas isomerize to branched chain alkanes। Major products are given below. Some minor products are also possible which you can think over. Minor products are generally not reported in the organic reaction। तो C3CH2 के 4 C3 anhydrous Cl3HCl जैसे N हेक्सेन तो मिलाएं तो ये बन जाएगा। फिर आता है एरोमेटाइजेशन। N-alkanes having 6 or the more carbon atoms on heating to 773 Kelvin at the 10 से 20 atmospheric pressure in the presence of the oxides of the vanadium, molybdenum or the chromium supported over the alumina get dehydrogenated and cyclized to benzene and its homologues। This reaction known as aromatization और reforming भी कहते हैं। जैसे ये है साइकिल है 1 2 3 4 5 6 का, इसमें Cr2O3 और द V2O5 और द MO2O3 मिलाएं तो ये बेंजीन बन जाता है। उसी तरह से टॉलिन इज मिथाइल डेरिवेटिव ऑफ द बेंजीन विच अल्केन डू सजेस्ट फॉर द प्रिपरेशन ऑफ द टॉलिन, तो उससे भी बना सकते हैं 7 वाले से। फिर रिएक्शन विद द स्टीम। मीथेन रिएक्ट्स विद द स्टीम एट 1273 केल्विन इन द प्रेजेंस ऑफ द निकल कैटलाइफ टू फॉर्म द कार्बन मोनोऑक्साइड और द डाइहाइड्रोजन। दिस मेथड इज यूज्ड फॉर द इंडस्ट्रियल प्रिपरेशन ऑफ द डाइहाइड्रोजन गैस। जैसे CH4 प्लस H2O, इसको निकल और हीट किए तो CO प्लस 3H2 बन गया। Pyrolysis higher alkanes on heating to the higher temperature decompose into lower alkanes, alkenes, etc. Such a decomposition reaction into smaller fragments by the application of the heat is called the pyrolysis or the cracking। जैसे C6H14 773 केल्विन पर C6H12 प्लस H2 और C4H8 और C2H6 और C3H6 C2H4 प्लस CH2 बन जाएगा क्रैकिंग। ये शायद उतना इम्पोर्टेंट नहीं है। उसके बाद फिर pyrolysis of the alkanes is believed to be a free radical reaction. Preparation of the oil gas or the petrol gas from the kerosene oil or the petrol involves the principle of the pyrolysis। For example, dodecane, a constituent of the kerosene oil, on heating to 973 Kelvin in the presence of the palladium or the nickel gives a mixture of the heptane and the pentane। जैसे C12H26 डोडेकेन है, इसको PTPDNI से किए तो हेप्टेन मिलेगा, पेंटेन मिलेगा और अदर प्रोडक्ट्स मिल जाएगा। उसके बाद फिर आता है कॉन्फॉर्मेशन। तो अल्केन्स contain carbon-carbon sigma bonds। Electron distribution of the sigma molecular orbital is symmetrical around the internuclear axis of the CC bond, which is not disturbed due to the rotation about its axis। This permits the free rotation about the CC single bond। This rotation results into different special arrangement of the atoms in the space which can change into one another। Such a special arrangement of the atoms which can be converted into one another by the rotation around the CC single bond are called the conformation or the conformers or the rotamers। Alkanes can thus have infinite number of the conformation by rotation around the CC single bond। However, it may be remembered that the rotation around a CC single bond is not completely free। It is hindered by a small energy barrier of the 1 to 20 kJ per mole due to big repulsive interaction between the adjacent bonds। Such a type of the repulsive interaction is called the torsional strain। Now the conformation of the ethane molecule C2H6 contains a carbon-carbon single bond with each carbon atom attached to 3 hydrogen atoms। Considering the ball and the stick models of the ethane keep one carbon atom stationary and rotate the other carbon atom around the free axis। This rotation results into infinite number of the special elements of the hydrogen atom attached to the one carbon atom with respect to the hydrogen atom attached to the other carbon atom। These are called the conformational isomers conformers। Thus there are infinite number of the conformations of the ethane. However, there are two extreme cases. One such conformation in which hydrogen atoms attached to two carbons are as close together as possible is called eclipsed conformation, and the other in which the hydrogens are as far apart as possible is known as the staggered conformation. Any other intermediate conformation is called the skew conformation. It may be remembered that in all the conformation the bond angles and the bond length remain the same. Eclipsed and the staggered conformation can be represented by the Fahrhoff and the Newman projection. तो पहला है Fahrhoff projection. In this projection, the molecule is viewed along with the molecular axis. It is then projected on the paper by drawing the central CC bond as a somewhat longer straight line. Upper end of the line is slightly tilted towards the right or the left hand side. The front carbon is shown at the lower end of the line, whereas the rear carbon is shown at the upper end. Each carbon has the three lines attached to it corresponding to 3 hydrogen atoms. The lines are inclined at an angle of 120 degrees to each other. Fahrhoff projections of the eclipsed and staggered conformation of the ethane are depicted in the figure 13.2. तो ये दिया हुआ है Fahrhoff projections of the ethane, जिसमें यहाँ पर eclipsed है, eclipsed में तीनों एक जैसे ऊपर ट्रायंगल, और फिर staggered दिया हुआ है. स्टैगर्ड में ये है और फिर ये ऊपर है तो इसमें ये केवल नीचे है. Now the Newman projection. In this projection, the molecule is viewed at the CC bond head-on. The carbon atom near to the eye is represented by a point. 3 hydrogen atom attached to the front carbon atoms are shown by the three lines drawn at an angle of 140 degrees to each other. The rear carbon atom away from the eye is represented by a circle, and the 3 hydrogen atoms are shown attached to it by the shorter line drawn at an angle of 140 degrees to each other. The Newman projections are depicted in the figure 13.3. तो इसमें आता है इक्लिप्स्ड, ये वाला है जिसमें सब एक दूसरे को घिरे हुए हैं. स्टैगर्ड में एंगल ऑफ रोटेशन और द एंगल ऑफ टॉर्सन और डायहेड्रल एंगल इसको कहते हैं. एंगल ऑफ रोटेशन कहते हैं, चाहे एंगल ऑफ रोटेशन कह सकते हैं, या एंगल ऑफ टॉर्सन, ये डायहेड्रल एंगल भी इसी को कहते हैं. न्यूमन प्रोजेक्शन ऑफ द इथेन दिया हुआ है. नाउ द रिलेटिव स्टेबिलिटी ऑफ द कॉन्फॉर्मेशन. As mentioned earlier, in the staggered form of the ethane, the electron clouds of the carbon-hydrogen bonds are as far apart as possible. Thus, there are minimum repulsive force, minimum energy, and the maximum stability of the molecule. On the other hand, when the staggered form changes into the eclipsed form, the electron clouds of the carbon-hydrogen bonds come closer to each other, resulting in the increase in the electron cloud repulsion. To check the increased repulsive force, molecule will have to possess more energy and thus has lesser stability. As already mentioned, the repulsive interaction between the electron clouds which affects the stability to a conformation is called a torsional strain. Magnitude of the torsional strain depends upon the angle of the rotation about a CC single bond. This angle is called either dihedral angle or a torsional angle. Of all the conformations of the ethane, the staggered form had the least torsional strain and the eclipsed form the maximum torsional strain. Therefore, a staggered conformation is more stable than the eclipsed conformation, hence more molecule largely remains in the staggered conformation, or we can say that it is preferred conformation. Thus, it may be inferred that rotation around the CC single bond in the ethane is not completely free. The energy difference between the two extreme forms is of the order of 12.5 kJ per mole, which very small. Even at the ordinary temperature, the ethane molecule gains thermal or the kinetic energy sufficient enough to overcome this energy barrier of 12.5 kJ per mole through intermolecular collision. Thus, it can be said that rotation about the carbon-carbon single bond in ethane is almost free for all practical purpose. It has not been possible to separate and isolate different conformation isomers of the ethane. Now the alkenes. Alkenes are the unsaturated hydrocarbons containing at least one double bond. What should be the general formula of the alkenes if there is one double bond between the two carbon atoms? In the alkenes, they must possess two hydrogen atoms less than the alkanes. Hence, the general formula for the alkenes is CnH2n. Alkenes are also known as the olefins. All forming since the first member of the ethylene or the ethene was found to form an oily liquid on the reaction with the chlorine. Now, the structure of the double bond. Carbon-carbon double bond in the alkane consists of the one strong sigma bond, bond enthalpy 397 kJ per mole due to the head-on overlapping of the sp2 hybridized orbitals, and one big pi bond enthalpy of 284 kJ more obtained by the lateral or the side edge overlapping of the two p orbitals of the two carbon atoms. The double bond is shorter in bond length 134 picometer and than the single bond 151 picometer. You have already read that the pi bond is weaker bond due to the poor sidewise overlapping between the two p orbitals. Thus, the presence of the pi bond makes alkenes behave as the source of the loosely held mobile electrons. Therefore, alkenes are easily attacked by the reagents of the compound which are in search of the electrons. Such reagents are called electrophilic reagents. The presence of the weaker pi bond makes alkenes unstable molecule in comparison to the alkanes, and thus alkenes can change into single bond compounds by combining with the electrophilic reagents. The strength of the double bond enthalpy of a coffee kilojoules per mole is greater than that of the carbon-carbon single bond. In ethane, bond enthalpy 348 kilojoules per mole. Orbital diagrams of the ethene molecule are shown in the figure 13.4 and the 13.5. Orbital picture of the ethene depicting a sigma bond only. तो sp2s इधर दिया हुआ है, sp2 दिया हुआ है सिग्मा और sp2 सिग्मा और sp2 और इधर फिर ये दिए हुए. Now the nomenclature. For the nomenclature of the alkenes in the IUP system, the longest chain of the carbon atom containing the double bond is selected. Numbering of the chain is done from the end which is near to the double bond. The suffix "-in" replaces "n" of the alkane. It may be remembered that the first member of the alkene series is the CH2 replacing "n" by 1 in the CnH2n, known as the methane, but has a very short life. As already mentioned, first stable member of the alkene series is C2H4, known as the ethylene, common to the ethene IUPAC. IUPAC name of a few members of the alkene are given below, जैसे कि प्रोपीन हो गया, इसका हो गया ब्यूट 1 इन हो गया, इसका ब्यूट 2 इन हो गया, इसका ब्यूटा 1 3 डाइन हो गया, इसका 2 मिथाइल प्रोप 1 इन हो गया, इसका 3 मिथाइल ब्यूट 1 इन हो गया. अब आता है कि ऑर्बिटल पिक्चर ऑफ द इथाइल शोइंग द फॉर्मेशन ऑफ द पाई क्लाउड एंड द बॉन्ड एंगल्स एंड द बॉन्ड लेंथ दिए हुए. तो पाई बॉन्ड दिया हुआ है, पाई क्लॉट दिया हुआ है और इधर 116.6, 134 पिकोमीटर, 110 पिकोमीटर और 121.7 पिकोमीटर दिया हुआ है. फिर राइट द IUPAC नेम्स ऑफ द फॉलोइंग कंपाउंड्स. जैसे ई दिया हुआ है, ये फिर ये दिया हुआ है, फिर ये दिया हुआ है और फिर ये दिया हुआ है. तो इसका सॉल्यूशन हो जाएगा कि इसका सॉल्यूशन 2,8 डाइमिथाइल 3,6 डेकाडाइन 1,3,5,6 ऑक्टा टेट्राइन हो जाएगा. फिर 2N प्रोपाइल पेंटवानिन हो जाएगा और 4 इथाइल 2,6 डाइमिथाइल डेकेन फोरिन हो जाएगा. फिर कैलकुलेट द नंबर ऑफ द सिग्मा एंड द पाई बॉन्ड इन द एबव स्ट्रक्चर. तो सिग्मा बॉन्ड, फिर पाई बॉन्ड और सिग्मा बॉन्ड पाई बॉन्ड सब में दिया हुआ है. अब आता है इसका आइसोमेरिज्म. तो alkenes are for both structural isomerism and the geometrical isomerism. Structural isomerism, as in the alkenes ethene C2H4 and the propanes C3H6 can have only one structure, but alkenes higher than the propane have different structure. Alkene posing C4H8 as the molecular formula can be written in the following three ways. कि पहला हम लिख सकते हैं ब्यूट 1 इन ऐसे, और दूसरा ब्यूट 2 इन इस तरफ लिख सकते हैं, फिर तीसरा में इस तरफ लिख सकते हैं 2 मिथाइल प्रोप 1 इन, और फिर स्ट्रक्चर 1 3 and 1 and 3, फिर 2 and 3 are the examples of the chain isomerism, whereas the structure 1 and 2 are the position isomers. फिर variety of structures and the IUPAC names of the different structural isomers of the alkenes corresponding to the C5H10. तो एक पेंट 1 इन हो गया, फिर दूसरा पेंट 2 इन हो गया, फिर तीसरा 2 मिथाइल ब्यूट 2 इन हो गया, फिर तीसरा 3 मिथाइल ब्यूट 1 इन हो गया और फिर चौथा 2 मिथाइल ब्यूट 1 इन हो गया. नाउ द ज्योमेट्रिकल आइसोमेरिज्म. doubly bonded carbon atoms have to satisfy the remaining two valence by joining with the two atoms or the groups. If the two atoms or the groups attached to each carbon atoms are different, they can be represented by the like a structure, or this like can be represented in the space by the following two ways. Now in two identical atoms, both the egg for both the bi lie on the same side of the double bond, but the two eggs for the two bi lie across the double bond or the opposite side of the double bond. This results in a different geometry of the A and B. That means disposition of the atom for the groups in the space in the two arrangement of the is different. Therefore, they are a stereoisomer. They would have the same geometry if the atom or the groups around the free double bond C bond can be rotated, but the rotation around free double C bond is not free. It is restricted. For understanding this concept, take two pieces of the strong cardboards and join them with the help of the two nails. Hold on one cardboard in your place in your hand and try to rotate the other. Can you really rotate the other cardboard? The answer is no. The rotation is restricted. This illustrates that the restricted rotation of the atoms or groups around the doubly bonded carbon atoms give rise to different geometry of such compounds. The stereoisomers of this type are called as the geometrical isomer. The isomer of the type A, in which the two identical atoms for the groups lie on the same side of the double bond, is called the fifth isomer, and the other isomer of the type B, in which the identical atoms for the group lie on the opposite side of the double bond, is called a trans isomer. The fifth and the trans isomers have the same structure but have different configuration, arrangement of atom or the groups in the space. Due to different arrangement of the atom or the groups in the space, these isomers differ in their property like the melting point, boiling point, dipole moment, solubility, etc. Geometrical or the fifth trans isomer of the but2 are represented as follow. तो फिफ्थ ब्यूट टू इन और ट्रांस ब्यूट टू इन, तो इधर बॉइलिंग पॉइंट दिया हुआ है 277 केल्विन, इधर बॉइलिंग पॉइंट 274 केल्विन दिया हुआ है. तो फिफ्थ फॉर्म ऑफ द एल्कीन इज फाउंड टू बी मोर पोलर देन द ट्रांस फॉर्म. फॉर एग्जांपल, डाइपोल मोमेंट ऑफ द फिफ्थ ब्यूट टू इन इज 0.33 dB, or where the dipole moment of the trans form is almost zero. It can be said that a trans but two in non-polar. This can be understood by drawing geometry of the two forms as given below, from which it is clear that in the trans butene the two methyl group are in the opposite direction. Therefore, the dipole moment of the cis3 bond cancels, thus making the trans form non-polar. cis butene और ट्रांस butene, तो cis butene का डायपोल मोमेंट 0.33 dB दिया हुआ है और ट्रांस का म्यू बराबर 0 है डायपोल मोमेंट. In the case of the solid, it is observed that the trans isomer of the has a higher melting point than the cis isomer. Geometrical or the fifth trans isomerism is also known by found by the alkenes of the type X by C double bond CXZ and the X by C double bond CZW. Draw the fifth and the trans isomer of the following compounds. Also write the IUPAC name. तो CH3 डबल बॉन्ड CH और C2H5 CH3 डबल बॉन्ड C2 C3 C2 H5. तो सिफ 1,2 डाइक्लोरोइथेन ट्रांस 1,2 डाइक्लोरोइथेन सिफ 3,4 डाई मिथाइल हेक्स 3 in and the trans 3,4 dimethyl hex 3 in. Which of the following compounds will for the fifth trans isomerism? तो सॉल्यूशन है कि 3 and the 4 in the structure 1 and 2 identical groups are attached to one of the doubly bonded carbon atoms. Now the preparation: alkenes on partial reduction with the calculated amount of the dihydrogen in the presence of the palladied charcoal partially deactivated with the poisons like the sulfur compounds or the quinoline gives alkenes. Partially deactivated palladied charcoal is known as the Lindlar's catalyst. Alkenes thus obtained are having fifth geometry. However, alkynes on reduction with the sodium in the liquid ammonia forms the trans alkene. जैसे कि दिया हुआ है अल्काइन्स दिया हुआ है, अल्काइन में ये किए तो फिफ्थ अल्कीन बन गया, फिर अल्काइन में Na लिक्विड NH3 किए तो ट्रांस अल्कीन बन गया, फिर इथाइन में किए तो इथीन बन गया और प्रोपाइन में किए तो प्रोपीन बन गया. तो with propene the obtained for geometrical isomerism, think for the region in support of your answer. From alkyl halide RX on heating with the alcoholic potassium hydroxide dissolved in the alcohol, say ethanol, eliminate one molecule of the halogen acid to form the alkene. This reaction is known as the dehydrohalogenation, that means removal of the halogen acid. This is example of the beta elimination reaction, since hydrogen atom is eliminated from the beta carbon atom next to the carbon to which the halogen is attached. तो इस पर दिया हुआ है अल्कोहलिक KOH और ये दिए हुए. तो नेचर ऑफ द हेलोजन एटम एंड द अल्काइल ग्रुप डिटरमाइन द रेट ऑफ द रिएक्शन. इट इज ऑब्जर्व्ड दैट फॉर द हेलोजन द रेट इज आयोडीन, फिर ब्रोमीन, फिर क्लोरीन, while for the alkyl group it is third, secondary or the primary. From the vicinal dihalides in which two halogen atoms are attached to the two adjacent carbon atoms are known as the vicinal dihalides. Vicinal dihalides on treatment with the zinc metal lose a molecule of the ZnX2 to form an alkene. This reaction is known as the dehydrohalogenation. तो C2Br Zn, CH2 डबल बॉन्ड CH2 और ZnBr2 बन गया. फिर CH3CHBr C3Br Zn, तो CH3CH2 और ZnBr 2 बन जाता है. Now from alcohols by the acidic dehydration, you have read during the nomenclature of different homologous series in the unit 12 that alcohols are the hydroxide derivatives of the alkanes. They are represented by the ROH, where R is the CnH2n plus 1. Alcohols on heating with the concentrated sulfuric acid form alkenes with the elimination of one Barter molecule. Since a Barter molecule is eliminated from the alcohol molecule in the presence of an acid, this reaction is known as the acidic dehydration of the alcohol. This reaction is also the example of the beta elimination reaction, since the OH group takes out the hydrogen atom from the beta carbon atom. तो ये है इथेनॉल में से कॉन्सनट्रेटेड H2SO4 की हैं तो इथीन बन गया. अल्फ़ा और बीटा पोजीशन से हाइड्रोजन हट गया होगा. अब है प्रॉपर्टीज. तो अल्कीन्स एज ए फिजिकल प्रॉपर्टी में कि अल्कीन्स एज ए क्लास रिएम्बल अल्केन्स इन द फिजिकल प्रॉपर्टीज एक्सेप्ट इन द टाइप्स ऑफ द आइसोमरिज्म एंड द डिफरेंस इन द पोलर नेचर. द फर्स्ट 3 members are the gaseous, the next 14 are the liquid, and the higher ones are the solid. Ethene is a colorless gas with a faint sweet smell. All other alkenes are colorless and odorless, insoluble in the water, but fairly soluble in the non-polar solvents like the benzene, petroleum, ether. Therefore, a regular increase in the boiling point with increase in the size, that means every CO2 group added increase boiling point by 20 to 30 Kelvin. Like alkanes, straight chain alkenes have higher boiling point than the isomeric branched chain compounds. Now the chemical properties. Alkenes are the rich source of the loosely held pi electrons, due to which they show addition reaction in which the electrophiles add on to the carbon-carbon double bond to form the addition product. Some reagents also add by the free radical mechanism. There are cases when under special condition alkenes also undergo free radical substitution reaction, oxidation and ozonolysis reaction are also quite prominent in the alkenes. A brief description of the different alkenes different reactions of the alkene is given below. तो पहला है कि addition of the dihydrogen. Alkenes add up one molecule of the dihydrogen gas in the presence of the finely divided nickel, platinum or the platinum to form the alkanes. The addition of the halogens like the bromine or the chlorine add up to the alkene to form the butanol dihalides. However, iodine does not show addition reaction under the normal condition. The reddish orange color of the bromine solution in carbon tetrachloride is discharged when bromine adds up to the unsaturated unsaturation fact. This reaction is used as a test for the unsaturation. Addition of the halogens to the alkenes is an example of electrophilic addition reaction involving cyclic halogen ion formation, which you will study in the higher classes. ये इथीन दिया हुआ है, इथीन से 1,2 डाइब्रोमोइथेन और फिर प्रोपीन से 1,2 डाइक्लोरोप्रोपेन बना दिए. Now the addition of the hydrogen halides. Hydrogen halides HCl, HBr, Hi add up to the alkenes to form the alkyl halides. The order of the reactivity of the hydrogen halide is the Hi, HBr, HCl. Like the addition of the halogen to the alkenes, addition of the hydrogen halides is also an example of the electrophilic addition reaction. Let us illustrate this by taking addition to the HBr to the symmetrical and the unsymmetrical alkenes. Addition reaction of the HBr to the unsymmetrical alkenes. Addition reaction of the HBr to the symmetrical alkenes. Similar group attached to the double bond take place by the electrophilic addition reaction mechanism. तो ये दिया हुआ है और फिर इसमें फिर ये बन जाएगा. उसके बाद फिर HBr ऐड करने पर Br यहाँ पर ऐड हो गया. उसके बाद फिर एडिशन रिएक्शन ऑफ द HBr टू द अनसिमेट्रिकल alkenes मार्कोनिकॉव रूल. हाउ विल HBr ऐड टू द प्रोपेन? द टू पॉसिबल प्रोडक्ट्स ऑफ R1 एंड 2. तो जैसे पहला हो गया कि Br है जो यहाँ पर बन गया 2 ब्रोमोप्रोपेन और फिर ये है कि ब्रोमोप्रोपेन यानी कि फर्स्ट में 1 पर आके लग गया. तो मार्कोनिकॉव a Russian chemist made a generalization in the 1859 after studying the such reaction in detail. This generalization led Markovnikov to frame a rule called the Markovnikov rule. This rule states that negative part of the addendum adding molecule gets attached to the carbon atom which possesses lesser number of the hydrogen atom. Thus, according to this rule, product 1, that means 2 bromopropane, is expected. In actual practice, this is the principal product of the reaction. This generalization of the Markovnikov rule can be better understood in terms of the mechanism of the reaction. तो mechanism, hydrogen bromide provides an electrophile H plus which attacks the double bond to form the carbocation as follow. H plus तो less stable primary carbocation or more stable secondary carbocation. The secondary carbocation is more stable than the primary carbocation, therefore the former predominates because it is formed at a faster rate. The carbocation B is attacked by the Br minus ion to form the product as follow. तो Br minus ion अटैक किया और 2 ब्रोमोप्रोपेन मेजर प्रोडक्ट बन गया. Now, anti-Markovnikov addition or peroxide effect or the Kharas effect. In the presence of the peroxide, addition of the HBr to the unsymmetrical alkene like the propane take place contrary to the Markovnikov rule. This happens only with the HBr but not with the HCl and HI. This addition reaction was observed by the MS Kharas and the FR Mayo in the 1933 at the University of the Chicago. This reaction is known as the peroxide or the Kharas effect or addition reaction or anti to the or addition reaction anti to the Markovnikov rule. तो HBr को जब ऐड किए तो पेरोक्साइड रहने पर Br यानी कि 1 ब्रोमोपेंटेन बन गया, यानी कि फैट पहले वाले कार्बन पर आके जुड़ गया। फिर मैकेनिज्म है कि पेरोक्साइड इफेक्ट प्रोसीड बाय द फ्री रेडिकल मैकेनिज्म एज गिवन बोलो। तो बेंजाइल कार्बो पेरोक्साइड है, इसको होमोलाइसिस करने पर ये फ्री रेडिकल बना। फिर दूसरा में फिर इसका होमोलाइसिस किया C6H5 तो फिर Br बना, और फिर होमोलाइसिस करने पर इसका ये लेस स्टेबल है क्योंकि 1 डिग्री है, और ये 2 डिग्री है तो मोर स्टेबल सेकेंडरी फ्री रेडिकल है। उसके बाद फिर होमोलाइसिस करने पर ये बना जो कि, और फिर यहाँ पर जोड़ने पर मेजर प्रोडक्ट बन गया। नाउ पाँचवा में फिर इन दोनों का करने पर होमोलाइसिस करने पर फिर माइनर प्रोडक्ट ये बन गया जो कि है जो कि माइनर प्रोडक्ट बना क्योंकि ये बीच में आके इधर आके जुड़ा है, और मेजर प्रोडक्ट जो किनारे वाला में जुड़ेगा वो हो जाएगा। The secondary free radical obtained in the above mechanism of step 2 is more stable than the primary. This explains the formation of the 1-bromopropane as the major product. It may be noted that the peroxide effect is not observed in addition of the HCl और HI, यानी कि HCl और एंड HI रहेगा तो peroxide effect नहीं होगा। This may be due to the fact that HCl bond between a stronger 430.5 kJ per mole than the HBr bond 363.7 kJ per mole is not cleaved by the free radical, whereas the HI bond is weaker and iodine free radicals combine to form iodine molecule instead of the adding to the double bond, वो सीधे iodine molecule ही बना देता है। फिर write the IOPAC name of the products obtained by the addition reaction of the HBr to the hex 1 in। तो पहला इन द प्रेजेंस ऑफ द पेरोक्साइड, इन द प्रेजेंस ऑफ द पेरोक्साइड एंड इन द एब्सेंस ऑफ द पेरोक्साइड। तो इन द प्रेजेंस ऑफ द पेरोक्साइड जब नो पेरोक्साइड, इन एब्सेंस में ये 2 ब्रोमोहेक्सेन बनेगा, और अगर पेरोक्साइड रहेगा तो 1 ब्रोमोहेक्सेन बन जाएगा। फिर एडिशन ऑफ द सल्फ्यूरिक एसिड, cold concentrated sulfuric acid adds to the alkenes in accordance with the Markovnikov rule to form the alkyl hydrogen sulfate by the electrophilic addition reaction। तो ये हो गया। फिर इथाइल हाइड्रोजन सल्फेट बन जाएगा, यहाँ पर इथाइल हाइड्रोजन सल्फेट बन जाएगा। फिर उसके बाद प्रोपाइल हाइड्रोजन सल्फेट बन जाएगा। उसके बाद फिर आता है एडिशन ऑफ वाटर। In the presence of a few drops of the concentrated sulfuric acid, alkenes react with the water to form the alcohol in accordance with the Markovnikov rule। 2-methyl H plus तो 2-methyl propane 2OL बन जाएगा। Now the oxidation, alkenes on reaction with cold dilute aqueous solution or the potassium permanganate Beer's reagent produce the vinyl glycols। Decolorization of the KMnO4 solution is used as a test for the unsaturation। जैसे डायल्यूट KMnO4 273 केल्विन पर लाया तो इथेन 1,2 डायोल यानी ग्लाइकोल बन गया। फिर डायल्यूट KMnO4 273 केल्विन प्रोपेन 1,2 डायोल ये बन गया। उसके बाद फिर आता है एसिडिक पोटेशियम परमैंगनेट और द एसिडिक पोटेशियम डाइक्रोमेट ऑक्सीडाइज alkenes to ketones और फिर डिपेंडिंग अपॉन द नेचर ऑफ द अल्कीन एंड द एक्सपेरिमेंटल कंडीशन। जैसे 2-methyl KMnO4 ऐड किया तो प्रोपेन 2,1 बन गया, और ब्यूट 2 में KMnO4 H प्लस तो इथेनोइक एसिड बन गया। फिर उसके बाद आता है ओजोनोलाइसिस। तो ओजोनोलाइसिस ऑफ द अल्कीन्स इन्वॉल्व द एडिशन ऑफ द ओजोन मॉलिक्यूल टू अल्कीन टू फॉर्म द ओजोनाइड एंड देन क्लीवेज ऑफ द ओजोनाइड बाय द ZnH2O to the smaller molecules। This reaction is highly useful for detecting the position of the double bond in the alkenes or the other unsaturated compounds। जैसे प्रोपीन है, प्रोपीन ओजोनाइड बन जाएगा, फिर Zn प्लस H2O डालेंगे तो इथेनॉल बन जाएगा और मिथेनॉल बन जाएगा। फिर 2-methyl प्रोपेन है, ओजोनाइड बन जाएगा, फिर Zn प्लस H2O करेंगे तो प्रोपेन 2,1 बन जाएगा। फिर आता है पॉलीमराइजेशन। तो यू आर फैमिलियर विथ द पॉलीथीन बैग्स एंड द पॉलीथीन शीट्स। पॉलीथीन इज ऑब्टेन्ड बाय द कॉम्बिनेशन ऑफ a large number of the ethane molecule at high temperature, high pressure and in the presence of the catalyst। The large molecule thus obtained are called the polymers। This reaction is known as the polymerization। The simple compounds from which the polymers are made are called the monomers. Other alkenes also go polymerization. तो हाई टेम्परेचर प्रेफर कैटलिस्ट पे देखेंगे तो पॉलीथीन बन जाएगा, और फिर हाई टेम्परेचर प्रेफर कैटलिस्ट पे देखेंगे तो पॉलीप्रीन बन जाएगा. Polymers are used for the manufacture of the plastic packs, squeeze bottles, refrigerator, dishes, toy, pipes, radio and the TV cabinet, etc. Polypropylene is used in the manufacture of the milk crates, plastic buckets and the other molded articles. Though these materials have now become common, excessive use of the polythene and the polypropylene is a matter of the great concern for all of the us. Now the alkynes. So like the alkynes are alpha unsaturated hydrocarbons. They contain at least one triple bond between the two carbon atoms. The number of the hydrogen atoms is still less in the alkynes as compared to the alkenes or the alkanes. Their general formula is CnH2n plus 2. 2n minus 2 है. The first stable member of the alkyne series is the ethane, which is properly known as the acetylene. Acetylene is used for arc welding purpose in the form of the oxyacetylene flame obtained by the mixing acetylene with oxygen gas. Alkynes are a starting material for a large number of the organic compounds, hence it is interesting to study the class of organic compounds. उसके बाद फिर आता है nomenclature and the isomerism. In common system, alkynes are named as the derivatives of the acetylene. In the IUPAC system, they are named as the derivatives of the corresponding alkanes, replacing "n" by the suffix "ine". The position of the triple bond is indicated by the first triply bonded carbon. Common and IUPAC name of a few number of the alkyne series are given in table 13.2. We have already learned that ethane and the propane have got only one structure, but there are two possible structures of the butane, but1-ene and the but2-ene. Since these two compounds differ in their structure due to their position of the triple bond, they are known as the position isomer. In how many ways you can construct the structure of the next homologue, that means the next alkyne with the molecular formula C5H8. Let us try to arrange 5 carbon atoms with a continuous chain and with a side chain. Following are the possible structure. तो स्ट्रक्चर दिया हुआ है पेंट वन आइन हो गया, पेंट टू इन हो गया, फिर 3 मिथाइल ब्यूट 1 इन हो गया. Structure 1 and 2 are the positional isomer, and structure 1 and 2 and 3 are the chain isomers. We write the structure of the different isomer corresponding to the fifth member of the alkyne series. Also write the IUPAC name of the all isomers. What type of the isomerism is exhibited by the different types of the isomers. Fifth member of the alkyne had the molecular formula C6H10. The possible isomers are, एक तो ये हो जाता है हेक्स 1 इन हो गया, दूसरा हेक्स 2 इन हो गया, तीसरा हेक्स 3 इन हो गया, फिर 3 मिथाइल पेंट 1 आयन हो गया, 4 मिथाइल पेंट 1 आयन हो गया, 4 मिथाइल पेंट 2 आयन हो गया, फिर 3 डाईमिथाइल पेंट 3 डाईमिथाइल ब्यूट 1 आयन हो गया. तो ये हेक्स आयन हो गया, फिर हेक्स 3 आयन हो गया, फिर 3 मिथाइल पेंट 1 आयन हो गया, फिर 4 मिथाइल पेंट 1 आयन हो गया, फिर 4 मिथाइल पेंट 2 आयन हो गया, और फिर 3 डाईमिथाइल ब्यूट 1 आयन हो गया. फिर पोजीशन एंड द चेन आइसोमरियम फोन बाय द डिफरेंट पेयर्स. उसके बाद फिर आता है स्ट्रक्चर एंड द ट्रिपल बॉन्ड. यहाँ पर दिया हुआ है कॉमन एंड द आईयूपीएसी नेम, कॉमन एंड द आईयूपीएसी नेम ऑफ द अल्काइंस दिए हुए. जैसे 2 है तो उसका एसिटिलीन हो जाएगा, इथाइन हो जाएगा. 3 है तो उसका मिथाइल एसिटिलीन प्रोपाइन हो जाएगा, और इसका है तो 4 है तो इथाइल एसिटिलीन या ब्यूट 1 आयन हो जाएगा, और डाईमिथाइल एसिटिलीन या ब्यूट 2 आयन हो जाएगा. उसके बाद फिर आता है स्ट्रक्चर ऑफ द ट्रिपल बॉन्ड. तो इसमें आता है इथाइन इज द सिम्पलेस्ट मॉलिक्यूल ऑफ द अल्काइन सीरीज. स्ट्रक्चर ऑफ द इथाइन इज शोन इन द फिगर 13.6. Each carbon atom of the ethane has 2 sp hybridized orbitals. Carbon-carbon sigma bond is obtained by the head-on overlapping of the 2 sp hybridized orbitals of the 2 carbon atoms. The remaining sp hybridized orbital of each carbon atom undergoes overlapping along with the internuclear axis with the 1s orbital of each of the 2 hydrogen atom, forming the 2 switch sigma bonds. H-switch bond angle is of 180 degree. Each carbon has 2 unhybridized p orbitals which are perpendicular to each other as well as to the plane of the cis sigma bond. The 2p orbital of the one carbon atom are parallel and to the 2p orbitals of the other carbon atom, which undergo lateral or the sidewise overlapping to form 2 pi bonds between the 2 carbon atoms. Thus, the ethane molecule consists of the one cis sigma bond, two CH sigma bond and two CC pi bonds. The strength of the C triple bond C bond enthalpy 823 kilojoules per mole is more than those of the CC bond enthalpy of 681 kilojoules per mole, and CC single bond enthalpy of 348 kilojoules per mole. The C triple bond C bond length is shorter 120 picometer than those of the C double bond C 133 picometer and CC 151 picometer. Electron cloud between two carbon atoms is cylindrically symmetrical about the internuclear axis. Thus the ethane is a linear molecule. Now the orbital picture of the ethane showing the sigma overlap or the pi overlap इधर दिया हुआ है. तो in the plane of the paper है, in the plane of the paper में दिया हुआ है, और इधर बिलो द प्लेन ऑफ द पेपर दिया हुआ है, फिर एबव द प्लेन ऑफ द पेपर दिया हुआ है, और इन द प्लेन ऑफ द पेपर दिया हुआ है. फिर ये इधर दिया हुआ है सिग्मा ओवरलैप और द पाई ओवरलैप इधर दिया हुआ है. नाउ द प्रिपरेशन. तो फ्रॉम द कैल्शियम कार्बाइड ऑन इंडस्ट्रियल स्केल ethane is prepared by treating calcium carbide with the butter. Calcium carbide is prepared by heating quicklime with the coke. Quicklime can be obtained by heating limestone as shown in the following reaction. जैसे CaCO3 को हीट करेंगे तो CaO प्लस CO2 मिल जाएगा. उसके बाद आता है कि CaCO को कार्बन के साथ करेंगे तो CaC2 यानी कैल्शियम कार्बाइड मिलेगा प्लस CO मिलेगा, और CaC2 प्लस H2O करेंगे तो COH2 प्लस C2H2 मिल जाएगा. उसके बाद आता है भिफनल डाइहैलाइड. तो भिफनल डाइहैलाइड्स on treatment with the alcoholic potassium hydroxide undergo dehydrogenation. One molecule of the hydrogen halide is eliminated to form alkynyl halide with on treatment with the soda lime gives the alkyne. जैसे अल्कोहल और KBr निकल जाएगा इसमें, फिर NaNH2 ऐड करेंगे और NaBr करेंगे तो ये बन जाएगा एसिटिलीन. प्रॉपर्टीज. Physical property of the alkynes follow the same trend of the alkenes and alkanes. First 3 members are the gases, the next 8 are the liquids, and the 8 higher ones are the solids. All alkynes are colorless. Ethane has a characteristic odor. Other members are the odorless. Alkynes are weakly polar in nature. They are lighter than the butter and immiscible with the butter, but soluble in the organic solvents like the ether. Carbon tetrachloride and the benzene. Their melting point, boiling point, and the density increases with the increase in the molar mass. फिर आता है chemical properties. Alkynes for acidic nature, addition reaction and the polymerization reaction as follow. Acidic character of the alkyne: sodium metal and the soda amide NaNH2 are strong bases. They react with the ethane to form the sodium acetylide with the liberation of the dihydrogen gas. These reactions have not been observed in the case of the ethene and the ethane, thus indicating that ethane is acidic in nature in comparison to the ethene and the ethane. Why it is so? Has it something to do with their structure and their hybridization? You have read that hydrogen atoms in the ethene are attached to the sp hybridized carbon atoms, whereas they are attached to the sp2 hybridized carbon atoms in the ethene and sp3 hybridized carbon atoms in the ethane. Due to maximum percentage of the S character 50%, the sp hybridized orbitals of the carbon atom in the ethane molecule have highest electronegativity. Hence, these attract the shared electron pair of the CH bond of the ethane to a greater extent than that of the sp2 hybridized orbitals of the carbon in the ethene and the sp3 hybridized orbitals of the carbon in the ethane. Thus, in the ethane hydrogen atoms can be liberated as protons more easily as compared to the ethene and the ethane. Hence, the hydrogen atoms of the ethane attached to the triply bonded carbon atom are acidic in the nature. You may note that the hydrogen atoms attached to the triply bonded carbon are acidic, but not all the hydrogen atoms of the alkalines. तो ये हो गया मोनोसोडियम इथेनाइड, मोनोसोडियम इथेनाइड हो गया, और इधर डाइसोडियम इथेनाइड हो गया, फिर इधर सोडियम प्रोपेनाइड हो गया. फिर आता है these reaction are not shown by the alkenes and the alkanes, hence used for the distinction between the alkenes and the alkanes. What about the reaction with but1 and the but2? Alkenes and the alkanes follow the following trend in their acidic behavior. सबसे ज़्यादा ये, फिर सबसे कम ये, और फिर इसमें आता है ये वाला, फिर ये वाला, और फिर ये वाला. फिर आता है acidic reaction. Alkyne contains a triple bond, so they add up to 2 molecules of the dihydrogen, halogen and hydrogen halides. Now the formation of the addition product take place according to the following step. इसको कहते हैं vinylic cation. The addition product formed depends upon the stability of the vinyl cation. Addition in the unsymmetrical alkynes take place according to the Markovnikov rule. Majority of the reaction of the alkynes are the examples of the electrophilic addition reaction. A few addition reactions are given below. तो पहला दिया हुआ है एडिशन ऑफ द डाई हाइड्रोजन, जैसे CH+1 ये फिर उसके बाद ये बन जाएगा, फिर इन्हें प्रोपेन बन जाएगा और फिर इधर प्रोपेन बन जाएगा, इधर प्रोपाइन से PDNI फिर प्रोपेन और प्रोपेन से फिर प्रोपेन बन जाएगा। फिर एडिशन ऑफ हेलोजन Br 1,2 डाईब्रोमो प्रोपेन बन जाएगा, फिर इधर ऐड करेंगे तो 1,1,2,2 टेट्रा ब्रोमो प्रोपेन बन जाएगा। फिर रेडिश ऑरेंज कलर ऑफ द सॉल्यूशन ऑफ द ब्रोमीन इन कार्बन टेट्राक्लोराइड इज डीक्लोराइड, दिस इज यूज्ड एज ए टेस्ट फॉर द unsaturation. Addition of the hydrogen halides. Two molecules of the hydrogen halides HCl, HBr, Hi add to the alkynes to form the gem dihalides in which the two halogens are attached to the same carbon atom, जैसे कि ब्रोमोइथेन फिर 1,1 डाईब्रोमो इथेन बन जाएगा। उसके बाद फिर आता है इधर, फिर ये बन गया 2 ब्रोमो प्रोपेन बन गया, फिर 2,2 डाईब्रोमो प्रोपेन बन गया। फिर एडिशन ऑफ द बाटर like alkanes when the alkynes are also immiscible and do not react with the butter. However, one molecule of the butter add to the alkenes on warming with the mercuric sulfate and dilute sulfuric acid at 333 Kelvin to form the carbonyl compounds, जैसे कि Hg प्लस और Hg2 प्लस H प्लस 333 करने पर आइसोमराइजेशन करने पर इथेनॉल बन गया, फिर Hg2 प्लस H प्लस 333 करने पर आइसोमराइजेशन करने पर प्रोपेनोन बन गया प्रोपाइन से और इधर इथाइन से। Now the polymerization, linear polymerization under the suitable condition, linear polymerization of the ethane take place to produce the polyacetylene or the polyethylene, which is high molecular weight polyalene containing repeating units of the CH feed and can be represented as this one under a special condition. This polymer conducts electricity. Thin film of the polyacetylene can be used as the electrodes in the battery. These films are good conductors, lighter and cheaper than the metal conductors. Now the cyclic polymerization. Ethane on passing through the red hot iron tube at 873 Kelvin undergoes cyclic polymerization. Three molecules polymerize to form the benzene, which is the starting molecule for the preparation of the derivative from the benzene, drugs and a large number of the other organic compounds. This is the best route for the entering from the aliphatic to the aromatic compounds as discussed below. जैसे रेड हॉट ट्यूब आयरन ट्यूब 873 केल्विन पर किए तो ये बेंजीन और ये बन गया। फिर हाउ विल यू कन्वर्ट इथेनोइक एसिड इनटू द बेंजीन, तो सॉल्यूशन है कि NaOH और फिर फिडोल में सोडा लैम किए तो फिर ये किया, फिर Na ड्राई बूट ईटर बन गया, फिर उसके बाद ये किया अल्कोहलिक केच किया, रेड हॉट आयरन ट्यूब किया तो लास्ट में फाइनली बेंजीन बन गया। ये शायद बढ़िया क्वेश्चन है। उसके बाद आता है एरोमेटिक हाइड्रोकार्बन। Aromatic hydrocarbon. These hydrocarbons are also known as the arenes since most of them possess pleasant odor, Greek aroma meaning pleasant or smelling. The class of the compound by named as the aromatic compounds. Most of the such compounds were found to be contain benzene ring. Benzene ring is highly unsaturated, but in majority of the reaction of the aromatic compounds, the unsaturation of the benzene ring is retained. However, there are examples of the aromatic hydrocarbon which do not contain a benzene ring, but instead contain other highly unsaturated ring. Aromatic compounds containing benzene rings are known as benzenoid, and those not containing a benzene ring are known as non-benzenoids. Some example of the arenes are given below. जैसे इधर दिया हुआ है, यह है बेंजीन, यह है टोलिन, यह है नेप्थलीन और यह है बाइफिनाइल। तो nomenclature and the isomerism. The nomenclature and the isomerism of the aromatic hydrocarbon has already been discussed in the unit 12. All 6 hydrogen atoms in benzene are equivalent, so it forms one and only one type of the monosubstituted product. When 2 hydrogen atoms in the benzene are replaced by the 2 similar or different monovalent atom or the group, 3 different position isomers are possible. The 1,2 or the 1,6 is known as the ortho, or the 1,3,1,5 are known as meta, and the 1,4 are para substituted compound. A few examples of the derivative of the benzene are given below. तो ये हो गया मिथाइल बेंजीन, टोलिन, 1,2 डाइमिथाइल बेंजीन, जिसको कहते हैं ऑर्थोजाइलिन। नाउ यहाँ पर फेडरिक अगस्ट किक्विल के बारे में दिया हुआ है। तो Friedrich August Kekule Friedrich August Kekule, a German chemist, was born in the 1829 at the Darmstadt in the Germany. He became professor in the 1856 and fellow of the Royal Society in the 1875. He made major contribution to the structure of structural organic chemistry by proposing in the 1858 that carbon atoms can join to one another to form the carbon chain to form the chains, and later in the 1855 he found an answer to the challenging problem of the benzene structure by suggesting that these chain can lose can close for can this chain can close to form closed rings. He gave the dynamic structural formula to the benzene, which forms the basis for the modern electronic structure. He described the discovery of the benzene structure later as, "I was sitting writing at my textbook, but the work did not progress. My thoughts were elsewhere. I turned my chair to the fire and dodged. Again the atoms were gambling before my eyes. This time the smaller group kept modestly in the background. My mental eye, rendered more acute by repeated vision of this kind, could now distinguish larger structure of the manifold conformation, long rows, sometimes more closely fitted together, all twisting and tumbling in the snake-like motion. But look by that. One of the snake had seized hold of its own tail, and the form whirled mockingly before my eyes, as if by a flash of lightning. I woke. I spent the rest of the night working out of the consequences of the hypothesis. Let us learn to dream, gentlemen, and then perhaps we shall learn the truth. But let us beware making our dream public before they have been approved by by the waking mind. 100 years later, on the occasion of the Kikul centenary celebration, a group of the compounds, heavy polybenzenoid compounds, have been named as the Kukulines. Now the 1,3-dimethyl 1,3-dimethyl benzene and the 1,4-dimethyl benzene, इसको कहते हैं मेटाजाइलिन, इसको कहते हैं पैराजाइलिन. A structure of the benzene by oscillated by the Michael Faraday in the 1825. The molecular formula of the benzene C6H6 indicates a high degree of the unsaturation. This molecular formula do not account for its relationship to the corresponding alkenes and the alkynes, which you have studied in the earlier section of this unit. What do you think about its possible structure? Due to its unique property and the unusual stability, it took several years to find its structure. Benzene was found to be a stable molecule and found to form a triazonide, which indicate the presence of a three double bond. Benzene was further Benzene was further found to produce one and only one monosubstituted derivative, which indicate that all the fixed carbon and the fixed hydrogen atoms of the benzene are identical. On the basis of this observation, August Kekule in 1855 proposed the following structure for the benzene, having cyclic arrangement of the fixed carbon atom with alternate single and double bonds and one hydrogen atom attached to the each carbon atom. The Kekule structure indicates the possibility of the two isomeric 1,2-dibromobenzenes. In one of the isomers, the bromine atoms are attached to the doubly bonded carbon atoms, whereas in the other they are attached to the singly bonded atoms. Now, however, benzene was found to form only one ortho-disubstituted product. This problem was overcome by the Kekule by suggesting that concept of oscillating nature of the double bonds in the benzene as given below. Even with this modification, Kekule's structure of the benzene fails to explain the unusual stability and the preference to the substitutional reaction with addition reaction, which could later on explained by the resonance and the stability of the benzene. According to the valence bond theory, the concept of the oscillating double bond in the benzene is now explained by the resonance. Benzene is a hybrid of the various reuniting structure. The two structure A and B given by the Kekule are the main contributing structure. The hybrid structure is represented by the inserting a circle on a dotted line in the hexagon as shown in the C. This circle represents the 6 electrons which are delocalized between the 6 carbon atoms of the benzene ring. The orbital overlapping gives us better picture about the structure of the benzene. All the other 6 carbon atoms in the benzene are sp2 hybridized. The two sp2 hybrid orbitals of each carbon atoms overlap with sp2 hybrid orbitals of the adjacent carbon atoms of the carbon to form the 6 sigma bonds, which are added in the hexagonal plane. The remaining sp2 hybrid orbitals of each carbon atom overlap with the s orbitals of the hydrogen atoms to form the 6 ch sigma bonds. Each carbon atom is now left with one hybrid p orbitals perpendicular to the plane of the ring as shown below. The unhabitable p orbital of the carbon atoms are close enough to form a pi bond. By the lateral overlap, there are two equal possibilities of the forming three pi bonds by the overlap of the p orbitals C1, C2, C3, C4, C5, C6, or the C2, C3, C4, C5, C6, C1 respectively, as shown by the following figures. So, structures shown in the figure 13.1a and the B correspond to the two equal structure with localized pi bond. The internuclear distance between all the carbon atoms in the ring has been determined by the X-ray diffraction to be the same. There is equal probability for the p orbital of each carbon atom to overlap with the p orbital of the adjacent carbon atom. This can be represented in the form of the two dot net rings of the electron clouds, one above and the one below the plane of the hexagonal ring as follow. इसको कहते हैं इलेक्ट्रॉन क्लाउड. फिर आता है द फिक्स पाई बॉन्ड. The fixed pi electrons are thus delocalized and can move freely about the fixed carbon nuclei instead of any two as shown in the figure, or the delocalized pi electrons cloud it is attracted more strongly by the nuclei of the carbon atoms than the electron cloud localized between the two carbon atoms. Therefore, the presence of the delocalized pi electrons in the benzene makes it more stable than the hypothetical cyclohexatriene. X-ray diffraction data reveals that benzene is a planar molecule. Had any one of the above structure of the benzene A or B been correct, two types of the cis bond lengths were respected. However, X-ray data indicates that all the fixed cis bond lengths are of the same order, 140 picometer, which is intermediate between the cis single bond 155 picometer and cis double bond 133 picometer. Thus, the absence of the pure double bond in the benzene accounts for the reluctance of the benzene to show the addition reaction under the normal condition, thus explaining the unusual behavior of the benzene. Aromaticity. Benzene was considered as a parent aromatic compound. Now the name is applied to all the ring system, whether or not having the benzene ring possessing the following characteristics. तो पहला होना चाहिए कि प्लेनरिटी होनी चाहिए, दूसरा कंप्लीट डिकोलोकेशन ऑफ द पाई इलेक्ट्रॉन्स इन द रिंग होना चाहिए, तीसरा के प्रेजेंस फॉर द 4n+2 पाई इलेक्ट्रॉन्स इन द रिंग वेयर n इज द इंटीजर है, n/0 1 2 है, और दिस इज ऑफन रेफर टू एज द हकल्स रूल. सम एग्जांपल ऑफ द एरोमेटिक कंपाउंड्स आर गिवन बिलो. ये हो गया बेंजीन, फिर हो गया साइक्लोपेंटाडाइन एनायन, फिर साइक्लोहेप्टाट्राइन कैटायन, यहाँ n/n है, 6 पाई इलेक्ट्रॉन्स है. फिर आ गया नेप्थलीन, फिर n/2 10 पाई इलेक्ट्रॉन्स है, फिर एंथ्राफीन और हो गया फेनीएंथ्रीन n/3 और 14 पाई इलेक्ट्रॉन्स है. Properties of the benzene. Benzene is commercially isolated from the coal tar. However, it may be prepared in the laboratory by the following method. पहला cyclic polymerization of the ethyne और दूसरा decarboxylation of the aromatic acid. Solid salt of the benzoic acid on heating with the soda lamps gives the benzene. जैसे COO Na plus NaHCO तो E बन गया Na2 plus Na2CO3 बन गया. फिर आता है रिडक्शन ऑफ द फिनोल. तो फिनोल इज रिड्यूस्ड टू द बेंजीन बाय पासिंग इट्स वेपर ओवर द हीटेड जिंक डस्ट. जैसे ई प्लस किए तो यहाँ पर ये बन गया. फिर आता है प्रॉपर्टीज. तो फिजिकल प्रॉपर्टीज, एरोमेटिक हाइड्रोकार्बन फॉर द नॉन पोलर मॉलिक्यूल एंड आर यूजुअली कलरलेस लिक्विड्स और द सॉलिड्स विद कैरेक्टरिस्टिक अरोमा. यू आर ऑल्सो फैमिलियर विद द नेफ्थलीन balls which are used in the toilets and for the preservation of the cloth because of the unique smell of the compound and the moth repellent property. Aromatic hydrocarbons are immiscible with the water but are rarely immiscible with the organic solvent. They burn with the shooty flame. Now the chemical properties. Arenes are characterized by the electrophilic substitution reaction. However, under special conditions, they can also undergo addition and oxidation reaction. For electrophilic substitution reaction, the common electrophilic substitution reactions of arenes are the nitration, halogenation, sulfonation, Friedel-Crafts alkylation, and the acylation reaction in which the attacking reagent is electrophile. Nitration. A nitro group is introduced into the benzene ring when benzene is heated with a mixture of the concentrated nitric acid and concentrated sulfuric acid nitrating mixture. उसके बाद आता है कॉन्सेंट्रेटेड HNO3 प्लस कॉन्सेंट्रेटेड H2SO4 323 से 333 केल्विन पर ये आ गया नाइट्रो बेंजीन बन जाता है. फिर इधर हेलोजिनेशन. तो arenes react with the halogens in the presence of the Lewis acid like the anhydrous FeCl3, FeBr3 और the LCl3 to yield the haloarenes. तो anhydrous LCl3 तो ये बन जाता है साइक्लोबेंजीन बन जाता है, साइक्लोबेंजीन. फिर सल्फोनेशन. द रिप्लेसमेंट ऑफ अ हाइड्रोजन एटम बाय अ सल्फोनिक एसिड ग्रुप इन द रिंग इज कॉल्ड द सल्फोनेशन. इट इज कैरिड आउट बाय द हीटिंग बेंजीन विद द फ्यूमिंग सल्फ्यूरिक एसिड. तो H2SO4 के साथ किए तो यहाँ पर बन जाएगा बेंजीन सल्फोनिक एसिड. उसके बाद आता है Friedel-Crafts alkylation. तो when benzene is treated with the alkyl halide in the presence of the anhydrous aluminum chloride, alkyl benzene is formed. तो anhydrous Al3 तो ये बन गया टॉलिन और इधर बन गया इथाइल बेंजीन बन गया. Why do we get isopropyl benzene on treating with benzene 1 with 1 chloropropane instead of the N-propyl benzene? तो Friedel-Crafts acylation reaction. The reaction of the benzene with an ethyl halide or the acid anhydride in the presence of the Lewis acid yields the ethyl benzene. Now एसिटाइल क्लोराइड हो गया एनहाइड्रस एल्फिल3 एसिटोफिनोन, फिर एसिटिक एनहाइड्राइड एनहाइड्रस एल्फिल3 पर ये बन जाता है. उसके बाद फिर आता है कि if the excess of the electrophilic reagents is used, further substitution reaction may take place in which the other hydrogen atoms of the benzene ring may also be successively replaced by the electrophile. For example, the benzene on treatment with the excess of the choline in the presence of the anhydrous L3 can convert to the hexachlorobenzene C6H6. इसको कहते हैं hexachlorobenzene C6H6 बन जाएगा जब anhydrous L3 डार्क और कोल्ड लेंगे तो. Now the mechanism of the electrophilic and substitution reaction according to the experimental evidence, SE substitution reactions are supposed to proceed by the following 3 steps. पहला है generation of the electrophile, formation of the carbocation intermediate, and removal of the proton from the carbocation intermediate. During chlorination, alkylation, and acylation of the benzene anhydrous L3 during a Lewis acid helps in the generation of the electrophiles acylium ions respectively by combining with the attacking reagents. तो पहला ये बन गया CCl फिर एल्फिल क्रोनियम आयन बन गया, फिर ये बन गया. फिर इन द केस ऑफ द नाइट्रेशन इलेक्ट्रोफाइल नाइट्रोनियम आयन Na2+ is produced by the transfer of a proton from the sulfuric acid to the nitric acid in the following manner. तो इससे फिर इसके बाद फिर प्रोटोनेटेड नाइट्रिक एसिड और फिर नाइट्रोनियम आयन बन जाता है. नाउ इट इज इंटरेस्टिंग to note that in the process of generation of the nitronium ion, sulfuric acid serve as an acid and nitric acid as a base, thus it is a simple acid-base equilibrium. फिर formation of the carbocation, attack of the electrophile results in the formation of a sigma complex for the areninium ion in which one of the carbon is sp3 hybridized. तो ये हो गया सिग्मा कॉम्प्लेक्स हो गया एरेनियम आयन और sp3 हाइब्रिडाइड कार्बन हो गया. फिर उसके बाद फिर आता है द एरेनियम आयन गेट स्टेबलाइज्ड बाय द रियोनेंस. उसको रियोनेंस से फिर एरेनियम आयन को स्टेबलाइज कर सकते हैं. फिर आता है सिग्मा कॉम्प्लेक्स और द एरेनियम आयन लूजेज इट्स एरोमेटिक कैरेक्टर बिकॉज डिलोकलाइजेशन ऑफ द इलेक्ट्रॉन्स स्टॉप at the sp3 hybridized carbon, removal of the proton to restore the aromatic character. Sigma complex release proton from the sp3 hybridized carbon on the attack by the L4- in the case of the halogenation, alkylation and acylation, and HFO4- in the case of the nitration. तो L4 की तो यहाँ पर E आ गया और इधर फिर किया तो यहाँ पर H2SO4 आ गया. Now the addition reaction. So under the Voyagorov condition, that means at the high temperature and at pressure in the presence of the nickel catalyst, hydrogenation of the benzene gives the cyclohexane. जैसे 3H2 करेंगे तो cyclohexane बन गया यानी कि बेंजीन खत्म. Under the ultraviolet light, 3 choline molecules add to the benzene to produce the benzene hexachloride C6H6Cl6 which is also called the gamagene. तो बेंजीन हेक्साक्लोराइड बन जाएगा जिसको कहेंगे BHC यानी कि गैमैक्जीन कहेंगे और UV 500 केल्विन पर. Combustion. When heated in the air, benzene burns with the footy flame producing CO2 and the H2O. तो C6H6 15/2 O2 6 CO2 plus H2O बन जाएगा. Now the general combustion reaction for any hydrocarbon may be given by the following chemical equation कि C6H by X plus pi by 4 O2 C6H by X plus pi by 4 O2 और XCO2 और फिर by 2 H2O बन जाएगा. Directive influence of a functional group in the monosubstituted benzene. When the monosubstituted benzene is subjected to further substitution, 3 possible disubstituted products are not formed in the equal amounts. 2 types of the behavior are observed, either ortho and the para products or the meta products is predominantly formed. It has also been observed that this behavior depends upon the nature of the substituents already present in the benzene ring and not on the nature of the entering group. This is known as the directive influence of the substituent. Reason for the ortho, para or the meta-directive nature of the group are discussed below. इसके बाद आता है ऑर्थो एंड द पैरा डायरेक्टिंग ग्रुप. द ग्रुप विच डायरेक्ट the incoming group to ortho and para position are called the ortho and the para directing group. As an example, let us discuss the directive influence of the phenolic group. Phenol is a reonine hybrid of the following structure. It is clear from the above reuniting of structure that the electron density is more on the ortho and the para position, hence the substitution takes place mainly at these position. However, it may be noted that the minus phi effect of the OH and the minus phi effect of the OH group also operates, due to which the electron density on the ortho and the para position of the benzene ring is slightly reduced, but the overall electron density increases at the position of the ring due to the reunions. Therefore, the OH group activates the benzene ring for the attack by an electrophile. Other examples of the activating groups are the NH2, NHR, NHCOC3, OCH3, CH3 and the Fe2H5. In the case of the aryl halides, halogens are moderately deactivating because of their strong minus phi effect. Overall electron density on the benzene ring decreases. It makes further substitution difficult. However, due to the reunions, the electron density of the ortho and the para position is greater than that of the meta position. Hence, they are also ortho and para reacting groups. Reunion structure of the chlorobenzene are given below. उसके बाद फिर आता है मेटा डायरेक्टिंग ग्रुप. द ग्रुप विच direct the incoming group to the meta position are called the meta directing group. Some example of the meta directing group are the NO2, CN, CHO, COR, FeOH, FeOR, FO3H, etc. Let us take the example of the nitro group. Nitro group reduces the electron density in the benzene ring due to its strong minus phi effect. Nitrobenzene is a reunion hybrid of the following structure. Then in this case, the overall electron density on the benzene ring decreases, making further substitution difficult. Therefore, these groups are also called the deactivating group. The electron density on the ortho and the para position is comparatively less than that at the meta position. Hence, the electrophile attacks on the comparatively electron-rich meta position, resulting in the meta position. Now the carcinogenicity and the toxicity. Benzene and the polynuclear hydrocarbon containing more than 2 benzene rings fused together and are toxic are said to be possess carcinogenic property. Such polynuclear hydrocarbons are formed on the incomplete combustion of the organic materials like the tobacco, coal and the petroleum. They enter into human body and undergo various biochemical reactions and finally damage DNA and cause cancer. Some of the carcinogenic hydrocarbons are given below. तो आता है इसमें 1,2 बेंजाथ्रीफिन, 3 मिथाइल क्लोरोथ्रीन, 1 बेंजापायरिन, 1,2,5,6 डाइबेंजा एंथ्राफिन, फिर 9,10 डाइमिथाइल 1,2 बेंजा एंथ्राफिन आता है जो कि कार्सिनोजेनिक है. फिर इसमें समरी है इसका कि hydrocarbons are the compounds of the carbon and hydrogen only. Hydrocarbons are mainly obtained from the coal and the petroleum, which are the major sources of the energy. Petrochemicals are the prominent starting materials used for the manufacture of a large number of the commercially important products. LPG, liquefied petroleum gas, and the CNG, compressed natural gas, the main sources of the energy for the domestic fuels and the automobile industry, are the obtained from the petroleum. Hydrocarbons are classified as the open chain saturated alkanes and the unsaturated alkanes and alkynes, cyclic, alicyclic and the aromatic according to their structure. The important reactions of the alkanes are the free radical substitution, combustion, oxidation and the aromatization. Alkenes and the alkynes undergo addition reaction, which are mainly electrophilic addition. Aromatic hydrocarbons, despite having unsaturation, undergo mainly electrophilic substitution and reaction. These undergo addition reaction and only under a special condition. Alkanes show conformational isomerism due to free rotation along the cis-sigma bond. Out of the staggered and the eclipsed conformation of the ethane, a staggered conformation is more stable as the hydrogen atoms are farthest apart. Alkenes exhibit geometrical cis-trans isomerism due to restricted rotation around the carbon-carbon double bond. Benzene and the benzoate compounds show aromatic character. Aromaticity, the property of the benzene aromatic, is possessed by the compounds having the specific electronic structure characterized by the Huckel 4n+2 pi electrons. Rule: the nature of the group of the substituents attached to the benzene ring is responsible for the activation or the deactivation of the benzene ring towards the further electrophilic substitution and also for the orientation of the incoming group. Some of the polynuclear hydrocarbons having fused benzene ring system have carcinogenic property.